somebody said AI is gonna take a job, I have been dismissive of him, since the only side I saw were chatbots like ChatGPT and Claude. Sure, they were fun, gimmicky, but other than giving me questionable answers to my assignments, I didn't find the same usefulness to them. I had seen the impressive apps, websites, and the drama surrounding the AI, and then started to feel maybe there is something to it. This lined up with two pretty convenient things in my life: an interesting project brewing in my mind, and a mobile carrier providing me with a pretty nice subscription to the Google AI models. Before I even opened whatever tool I was going to use, I needed to actually understand what I was going to build, what I had versus what the AI will provide. So, with a free weekend, I began. The rough idea was to build a truss engine of sorts with capabilities of 2D. It would sit in the middle domain of being complex enough to be actually meaningful and simple enough to have fun with and mess with. To begin was defining the actual core, the solvers. Put it simply, the entire physics engine is built on Hooke's law. Force equals stiffness times displacement. That's it. That's the whole idea. The stiffness of any given beam depends on three things: the material, how stiff it is, the cross-section area, how thick it is, and the length. Put those together, you get the formula. Beams in real life aren't lined up nicely against the horizontal or the vertical axis. They are angled all over the place. If I push a diagonal beam straight down, it doesn't just resist vertically, some of that forces get transferred into the x direction too. To handle this, you need a transformation matrix. We take the cosine and the sine of the beam's angle, bake them into a 4x4 matrix. This tells the computer how to split the force across x and y. Once you have the massive structure matrix, it's just Hooke's law all over again, but in linear algebra form, F equals to k dot u. You invert the stiffness matrix multiplied by the force you drew, and you get the exact displacements. In theory, this should be all to build the basic 2D solver. So I told the AI to do something along the lines that, hey, I want to build a 2D truss solver in Python, here's the theory, and then it began. As I said before, I wanted it to be fun, so instead of relying on quick shortcuts and hotkeys, I went with gesture-based and contextual clues. The basic gist of controls is as following. Left-click anywhere in the viewport makes a point. 2 points auto-connect to a beam. Holding left-click produces an arrow that you can define its angle, its magnitude. Right-click and you get pie menus instead of sidebars or contextual-based menus. With the general idea of UX there, I asked the AI to build what I envisioned, and this is where it struggled more than UX, since it's something not decisive like maths, The arrow caused issues like weird scaling. A lot of UI simply didn't scale properly, and even right now, it's quite a lacking one. It is one of those things I believe needs focus on and still requires a person. The UI though, unlike the UX, I think it did a much better job with the UI. I wanted the aero style of early 2000s and the AI did deliver. I did not give it much detail, so it was going off the basic description, and I think it got the gist really nicely. But once again, like the UX, it doesn't have the polish. Now, with something I could show to the people and look presentable enough, the question is it actually good? Is it actually able to solve reliably enough? To prove that our solver works, we are going to have an example question. Solve it ourselves, then in an application. The question is as follows. A simple truss question consisting of 3 members, one 500 Newton downward load, a built support and a roller support. We are going to see what the computer should do and what it actually does. First, the computer calculates the local spring stiffness for all 3 beams. For simplicity, let's say E times A is 100,000. The bottom beam is 6 meters long, so the stiffness is 16,666. The diagonals are 5 meters long, so their stiffness is 20,000. Then we apply the transformation matrix I mentioned earlier. For the left beam, the angle is 53.1 degrees. The engine calculates the sine and cosine and multiplies that 4,000 stiffness through the trigonometric matrix to split it into x and y stiffness. Now we assemble the Sudoku board. We have 3 nodes and each can move in x and y, so we get a 6 by 6 matrix. But if we apply a force to a floating structure, it just accelerates into deep space, so we have to pin it down to the ground. Node 1 is a pin, meaning it cannot move in x or y. Node 2 is a roller, meaning it can only move in x. To tell the math engine this, we literally just cross out those rows and columns in the matrix. This leaves us with a neat, solvable 3 by 3 matrix. We invert it, multiply by our 500 kN load, and boom, we get our exact nodal displacements. The software then takes those millimeter displacements, calculates how much each beam was stretched, and multiplies by the Young modulus to give us final stress values. But it all happens in a fraction of a millisecond every time we move a mouse. And now we look at the actual application, and as you can see, we get the same results. Now with a validated solver, we can do stupid stuff like increasing the force. What matters with every project is the scale of it, and I personally think for a 3-day project this turned out really nice. But that said, I still do wish to continue this project, and there is a lot like I want to do, like add 3D. Or before that improvement, I would like to add to this existing stuff like the viewport, with stuff like controls for pan and zoom, weighted calculations considering the mass and the gravity in calculations, ability to add materials and actually pull them from a reasonable database, implement section modulus calculations for advanced failure modes like buckling. There's a lot lacking with what I have already. I realize this even though I'm not a skilled coder. Even I can tell the code written by AI in some places is inefficient, but once again, for the scale of my project, it's not big enough to matter. A tool is merely a means to define the product. Without someone directing it, it can't produce. The day we let the tool be the director, we will become its means. What I mean by this is, I now do see the real threat that AI will pose to jobs and uncertainty of the future, but denying it or letting it completely control isn't the fix. It's to understand it as a tool and use it as the helm to direct your ship. I went into this thinking AI was mostly marketing, dress up like a chatbot, and I came out of it thinking that it's a real tool, and I still can't say how big it will get, or I don't think anyone can, but I'm not dismissive of it anymore. And with that, we come to the conclusion of this. I'd like to thank everyone for watching, and if you have anything you want to talk about, you may write about it in the comments. Thank you once again.